wind condition, rain.
Sorry? I, yeah, Arkodeep.
Wind condition, rain.
Correct. So wind condition, rain, the temperature, humidity, all that will play a lot of aspects when you're flying the drone, especially like fixed wing, okay, or even the normal multi-rotor or rotorcraft drones also, or hybrid drone, any type of drone you're flying, or even normal our civil airlines or commercial airlines what we fly, weather and meteorology plays a very important role. Okay, as a responsible pilot, you should know what is the current weather conditions. You should know what is will be the forecast, what is been forecast provided about the weather in next 2 hours, 4 hours, 6 hours, depending upon your flight. For example, you are flying from UK to Sydney. So if you see, the weather in UK would be different, whereas the weather in Sydney would be different, right? Because they are two different locations. UK is in northern hemisphere at somewhere around 55 latitude, whereas Sydney is in the southern hemisphere. So again, from a season perspective also, the weather would be different. So you need to know, and then you're crossing so much large area of the earth surface, so you will be passing through a different locations, and every location will have its own weather patterns, or it will be having its own weather cycle. Okay, so when you're flying over Kazakhstan, probably the weather would be different. When you're flying over Himalayas, there would be a different weather. When you're flying over Indonesia, Thailand area, it would be different. As you cross Indonesia and you're over the sea, their weather would be different. As you reach Australian Peninsula, then probably that location will have its different weather. So every, I would say 50 to 100 kilometers, there would be difference in the weather. Like even in Mumbai, we have seen, right? If I am staying in suburb, and if I go to South Bombay, the weather would be different, because it's almost like 30-40 kilometers different away from each other. The Mumbai suburban and Mumbai South Bombay, they are at least 30 to 40 kilometers away from each other. So whether there will be difference in the weather. Sometimes it is raining very heavily in South Bombay, whereas in suburb it will not be raining, or sometimes it is raining in suburban but it's not raining in South Bombay. It happens that way. Or even if I go to Palghar area or Surat area, which is maybe 100-120 kilometers or 200 kilometers away, or 300 kilometers away, there would be a difference in the weather. So from region to region it will change. Okay, so that is what we are going to see in the topic weather and meteorology. This topic is also an important topic with respect to the civil airlines. When you go for CPL training also, there is a separate study item for the weather and meteorology. It's a separate topic in itself. Okay, you have a one book also. What book you are using, Arkadeep, for weather and meteorology?
Actually, I am using the book which my institute provided, but arts see something it is also good, I guess.
Yes, so there is a book by name Mr. I.C. Joshi.
I.C. Joshi, yeah.
Right? That's the best and most preferred book. Or you purchase that book also. It talks in detail about the weather and meteorology. Okay, so let's see now what does covers inside the weather and meteorology. First topic is to know the atmosphere, because Earth is covered by the atmosphere, which protect us from the dangerous radiation from the sun. Okay, so this atmosphere is nothing but it's a layer of gases that envelops our planet. Okay, what are these gases? It could be nitrogen, oxygen, hydrogen, carbon dioxide. All this will be covered in this atmosphere. Okay, the Earth atmosphere varies vertically and horizontally in parameters. Okay. So there are 4 parameters which will vary vertically and horizontally, like pressure, temperature, humidity, and density. Okay. So if you go from location to location, the pressure would be different, temperature would be different, humidity would be there different, density would be different. Like for example, since I am staying in Mumbai, humidity is very high. Okay, even because humidity high, the temperature will also high. Pressure would be definitely what would be there at, since I am very close to the sea. But as I climb, like I go to Lonavala, their humidity will be very less. So it will be like a dry weather, cooler compared to what Mumbai is there. Lonavala will be much more cooler. As I go further to Mahabaleshwar, again that is little bit higher compared to Mumbai. So that will again the humidity will be almost very minimal Okay, temperature will drop again, but pressure might increase little bit. Pressure would be increase over there. Density again depending upon the type. Okay, whether it is a what time like you are being at that part. So again time perspective also, the density, pressure, temperature, humidity will change. Okay, in the night, the for example, if the temperature at Lonavala right now is somewhere around, let's say, 25 degree, example, okay, 25-26 degree, in the night it may further drop. It can become 23, 22 also. Okay, Mahabaleshwar it can be go up to 20 or 19 also, depending on, like, if you go to Uti or Kodaikanal, they are like 8,000 meters in height, 6,000, 8,000 meters. So there you will see more cooler temperature. Okay, in fact, if you go to Kodaikanal now, you will not feel that you are in summer. You will feel very cold over there. Even in the restaurant, they give you hot water to drink, not the cold normal regular water. Okay, so much cold is there at those locations. So higher you go, the temperature will reduce. That is what we are going to show. It is saying Earth atmosphere varies vertically and horizontally in parameters for pressure, temperature, humidity, and density. Okay, so remember these four words: pressure, temperature, humidity, and density varies vertically as well as horizontally. Okay, so if you see here, troposphere, which we starts from the ground till 12 kilometers. Okay, so 12 to 18 kilometers is your troposphere, in which actually your hot air balloons or your civilian airlines, aeroplanes, which normally flies. Beyond troposphere is stratospheres, which starts from 11 kilometers, it goes up to 50 kilometers. Then you have a mesospheres, in which you normally see the meteors or rockets flying. So that is somewhere around 40-50 kilometers. It goes up to 80-90 kilometers. Then you have a thermosphere, where you it starts from 80-90 kilometers, it goes up to 800 kilometers. Whereas exospheres, where actually your satellites, so basically your satellites in both zones, thermospheres as well as exospheres also in that range, because you are like International Space Station is moving around in its orbit in at 400 kilometers. Okay, whereas your Hubble telescope is little bit higher compared to your International Space Station. Okay, or even the other satellites, whether it is communication satellites or mobile satellites or weather satellites, whatever the satellites are there, they will be in this range. Okay, more important is about the troposphere. If you see the troposphere temperature is, it varies from 15 degrees to minus 56.5 degrees. Okay, so it will vary. So it will vary vertically as well as horizontally. So 15 degree may be at daytime, but in the night time it could be little bit less also. Okay, standard temperature I am talking about. Okay, so depends, varies vertically as well as horizontally, even in the particular troposphere location also. So troposphere is completely area where maximum activity is happening. Your all the aeroplanes are flying, your hot air balloons or any activity related to flying is happening into troposphere. So even our drone what we are flying will be flying in troposphere. Okay, that's all about the atmosphere. Any questions over here?
Yes.
No, sir.
Okay. So weather is the state of atmosphere describing, for the example, degree to which it is hot or cold, wet or dry, calm or stormy, clear or cloudy. So it is basically a state which describes time. Like if you see now outside, it is sunny, right? If you can see outside your window, you will see today the climate is completely dry and sunny, or probably hot also. Okay, couple of days back it was little bit uh, calm or stormy or maybe cloudy kind of environment it was there, but today we can see it is very good, clear sky. I can see up air in the no. So weather, but however, weather is the one factor in which the modern aviation, over which man has no control. If you see the weather stations or the data what we have almost, we are studying weather and meteorology for almost like 200 years, 300 years. Okay, uh, but still having so much data now, we have done so much technology advancement, we have supercomputers used by this weather forecasting department and bodies and all the things, but still the weather is sometimes cannot be predicted 100% accurately, cannot be predicted because you do not have a control over it. All of a sudden in Arabian Sea there will be a low pressure will create it. Now why does that low pressure create, nobody knows, or you can't predict. Like even we're trying to understand the weather more and more by seeing the patterns, but we still have not had that 100%. But we are trying the learn from the historical data. So one normally, for example, today is 10th of June. So we'll normally see, okay, what was the condition last year on the same day? What was before that? So like that, maybe last 10 years, 20 years, I will see the pattern and I will try to predict this amount of the same weather and try to see whether my prediction is coming accurate or not. That is how I am actually learning and predicting or forecasting the weather. But sometimes it works properly, sometimes it goes wrong also. Lot of time, MET says that okay, it is going to rain today, it doesn't rain. Sometimes they don't predict that it is not going to rain, or it is not, I mean, sometimes they don't say talk anything about it and all of a sudden the rain comes. So the weather also over the period of time changes. Like abhi sunny dikh raha hai, maybe in the afternoon it will become cloudy. Okay, so it depends upon how the patterns work. So there are a lot of factors which works. Like it could be a temperature, it could be a wind. These are the two important aspects which will work. So as your, because of the sun, the oceans heat up, so it will create a lot of hot vapors, and that will flow, that will become a cloud. That cycling will happen. Again it will mix with the cold air, it will create some kind of rainy scenario and all the thing. Like if I see, I now if I see it, I cannot see the sunlight. Okay, in just I was talking to you, it was clear sunlight I was seeing outside the window, but now I see it is little bit covered by some cloud. Okay, so that sunlight is not that. But if I see very far, I can see other location, I can see the sunlight. So again, or maybe a particular small area will be covered by the cloud or something like that, or maybe a large area. It depends again the type of clouds also. So that we'll see more in detail in this topic. Okay. So meteorology is a branch of atmospheric science which includes atmospheric chemistry and atmospheric physics, with a major focus on weather forecasting. So meteorology, what we talk or we learn, is basically for weather forecasting. To understand the meteorological hazards, their effects on aircraft, and how to minimize the risk possessed by those hazards. So as a responsible pilot, you need to understand the weather first. The meteorological hazards, what it can happen, because of all of a sudden it is going to rain, or it could become a cloudy, you can have a turbulent atmosphere at that point in time, or maybe you will have a lot of hot air. So the flying will be more difficult, where you will be consuming a lot of power, because if your air become thinner, so it is very difficult when you flying in a hot summer because air is thinner. Okay, in that scenario you may have to use more fuel. So more fuel consumption is happening in summer season compared to winter season, because winter season your air will be thicker, so your aeroplane will have more air to glide or more air to lift. Okay, so again depending upon the seasons also, your flying conditions will differ. To identify the weather information that is required for each flight, so every time you are flying your aeroplane, let's say even I am flying on a same route for last 6 months, every time I'm filing my flight plan, I need to know the weather on that point in time, as well as the weather for next maybe 2 hours, 4 hours, or 5 6 hours, depending upon my time of the flight. If I'm flying from Mumbai to Delhi, I need to know what is the weather at Mumbai, I need to know what is the weather at Surat, I need to know what is the weather at Vadodara, I need to know what is the weather at probably Ahmedabad, I need to know what is the weather at Rajasthan area, maybe Jaipur, Udaipur, and then subsequently at Delhi. So whatever my flight plan is there, I need to see on that plan whatever the cities or whatever the airports are there or nearby airports are there, what is the current weather situation and what is the forecast given by them for next 2 hours, 4 hours, 6 hours, 8 hours, whatever it is. I need to see that. Okay, I need to know, I need to have some emergency plan or a backup plan in case the weather goes according to the forecast, or it is impacting my flying skills or my flying requirements or my flight plan. Yes, Arpadik.
Sir, do you have metadata for drones as well?
Yes, I'm coming to that. Okay, so when we talk about to analyze this, from where we will get this data? To analyze and evaluate weather information before flight and in flight. So that is what where we will get the data from METAR. So next slide is all about that. Okay. So knowledge of meteorology will least enable the aviator to anticipate some of the difficulties which weather may cause. Okay, just give me a moment. I have a call. Okay, sorry, I got a call from office. I have to get some parcel, so that's why. Okay, so knowledge of meteorology will at least enable the aviator. Okay, so we are talking from the commercial aeroplane or flying the aircraft, but from the perspective of the drone also. But currently, whatever the drone we are flying in a very limited space. Okay, so there is not much, but at least particular area. Like tomorrow, we are going to Igatpuri. So the current weather what we see in Mumbai and the weather what we will see in Igatpuri location is differ, because it differs with the altitude also, location wise also, the area wise also. Okay, so the see Mumbai weather is humid weather, whereas Igatpuri and Vaitarna location, it's probably what we the forest. It will have more trees, watery bodies are there. It is at high altitude also, so that location will be much cooler compared to what you see. So as you pass from Mumbai to Shahpur and you cross the Shahpur area, you will see the difference in the temperature. You will feel good. As you reach Igatpuri, Igatpuri is also called as fog city. Okay, so you will see foggy. You will see fog and all that thing forming at that location, even in summer also. Okay, so when you go near to our location, the flying location, it will be completely a different environment itself. The weather will be completely different what we see weather right now here in Mumbai. Okay, so to anticipate that weather, basically we need to know how to see. So METAR is the meteorological aerodrome report. METAR gives us the required data such as wind direction, wind speed, etc. needed for safe flying. From a drone operation, we need to cross check the METAR for safe and secure operation, where we don't risk the drone. So for example, see, METAR is more perspective with the civil airlines flying also, because you will be flying your aircraft from some of the airport, right? So every airport will be releasing their own METAR data. So now when you are seeing the METAR, okay, normally earlier the METAR was like a normal, SMS kind of thing, small textual information used to come. But nowadays, because of the technological advancement, you can see the metadata in a much easier, understandable, readable format on the respective websites or meta websites also, meta websites also, with respect to the location. Like if you want to see the METAR for Mumbai, you can go to that website of Mumbai airport. Okay, or you want to see for Delhi, you can go to Delhi, or you can go to Nasik. Like for example, for us, the nearest airport is Nasik. But again, if you see Nasik from my location, it is almost like 50-60 kilometers away. So maybe the weather at the airport could be different, and weather at my location where I am flying the drone might be little bit different also. Okay, so not necessary if it is raining at Nasik airport, that doesn't mean that it is raining at my location, or if it is raining at my location, doesn't mean that it will be raining at Nasik location. So we really don't have much of the metadata with respect to the drone flying, until unless we are like, for example, if I'm flying a drone in Mumbai, then I can refer Mumbai airport. So normally it should be somewhere around, I would say, we can refer around 12 to 50 kilometers, that is 10 to 50 kilometers of that range. You can use the existing current airport METAR data. But if it is go beyond 50 kilometers, then it is not applicable. Like for example, I cannot use the METAR what is applicable for Mumbai airport for my Igatpuri, because I am almost 180 kilometers away from the airport, and I am again at a different elevation again. So maybe that weather report of Mumbai airport will not be applicable for me for my location. Or even nearest airport from my location is Nasik, which is almost 60 kilometers, okay, 60-70 kilometers from it. so it is not really applicable to my location. So maybe I will try to understand, uh, use some other app which can give me a location perspective of weather status. But from a drone perspective or a drone pilot's perspective, you should know how to read the METAR, or what information do you get from the METAR data. Okay, so let's see couple of METARs. I think Arkodeep, you might be using some websites, right, for the METAR. Are you using any kind of,
Yes.
what
Um,
what are you using?
Sir, you can just search in the Google and you will get
So
it.
I'm just I normally we type METAR and we say all METSAT. Okay.
Uh,
Okay. So I'm just showing you just for your reference, both of you. So I'll just type METAR Mumbai and you see the first site. So you can open over here. So this is Chhatrapati Shivaji International Airport. Okay, you can see Mumbai, India. The latitude of Mumbai is 19 degree, longitude is 72 degree east. Elevation, you can see yesterday I was talking about, it is 8 meters. And the current weather observation, this was 30 minutes ago, the report was published. It is 5:30 UTC. So the, as I told you, the international uh, time coordinates are being used in civil aviations. Okay. Currently, wind is flowing at 10 knots from northwest northwest. Temperature is 31 degree. Humidity is 59 percentage. Pressure is 107 hectopascal. Visibility is 4,000 meters. That means 4 kilometers visibility is there. Some scattered clouds at height of 2,000. Some scattered cloud at 2,000. Little bit hazy, but not much worry part. Okay. And what is the forecast? If you see on the right side, there is a forecast. Okay, that is 11:30. Okay, current, as per the current time forecast. This is for 6:00 UTC. The report was made 1 hour back. Forecast valid from 10 at 06 UTC till 11 to 12 UTC. Same wind speed is there compared to current wind speed. So 10, sometimes there is a difference, like it might be showing currently 6 knots and they will predict like it may be 15 knots or something like that. Visibility is almost going to remain same. Scattered cloud is also same, haze and all the things. So not much difference in the forecast currently. Okay. So normally when you see the METAR, I think you will be seeing the metadata something like this. So you need to interpret here, like this is the station ID, then the time, then the wind speed, the visibility, scattered cloud at 2000, scattered cloud at 2005. Okay, 31 degrees the temperature, 22 is the humidity, then your standard pressure is this, but no significant change or no significant difference in the weather. Nothing much worry about the current weather. It's a good weather for flying conditions. That is what it is saying. Similarly, if I see for, let's say, Surat, okay, I can just type Surat. Okay. So I can see here for Surat.
you can also go to Flight Radar 24 and you will get all that data.
Yeah, yeah. Even here also I can change. Even here, if I just change, from Mumbai, I can change it to, let's say, uh, Delhi. Why did not show me? Okay, here also, if I change, it will show me about it. So like for example, Indira Gandhi Airport. Okay, and why I'm just changing, because I want to have a separate tab. That's why I was changing it. Okay, so for Delhi, you see New Delhi latitude is 28, longitude is 77. Elevation, now you see here, it is 220 meters. Okay, just a minute, I'm getting a call. Okay, sorry. That was the call from one of our students who is actually traveling from Mumbai to Tanzania, and he's carrying a thermal drone. So last time when he carried the thermal drone. While going from Mumbai to that location, he didn't have any problem. But while returning back, his flight was via Dubai. Okay, so at Dubai airport, he was stopped and his drone was confiscated, and he was not allowed to carry that drone back to Mumbai. Okay, so he had a lot of trouble and challenges at that point in time. So he was asking that again, I'm going, so how to, what to do and what not to do and all the things. So last time also when we were discussing about this to him, I told him that you need to declare, you need to define why you are taking, what is the purpose. You should have a letter from the company for what purpose you are taking that drone to that location, and that location area, whatever. And then second, last time when he was taking that drone was not registered on the Digital Sky platform. So I told him this time you register that drone on the Digital Sky platform. And even that point in time, last time he was not a certified pilot also. That's why he has done the certification with us, and he is now a certified pilot. But his license is still not come. Okay, it is going to take another 7 to 10 days time for his license to come. Okay, so he was asking whether I can get a soft copy of the license. So I said, okay, wait for a couple of days, 1 or 2 days. By the time you reach Tanzania, and maybe max by Friday, you should get your soft copy of your license. Okay, hard copy will take some time, but the soft copy can be available. That's what I told you. Okay, so that's how people encounter or ask for different scenarios. So uska drone tha DJI 30T, which is a very good drone for actually thermal surveillance as well as RGB kind of flying. So basically, they are doing the thermal analysis of the wildlife over there. The migrations and all that thing. So for that purpose, they use those drones in that area. Okay, so coming back to our topic, like if you see Indira Gandhi International Airport, the elevation is 220 meters, whereas Mumbai is 8 meters. Okay, so you see the difference in the elevation. The report was made 33 minutes ago. See the wind speed here is 6 knots compared to Mumbai, it was 10 knots. Temperature is 39, so little bit temperature is at higher. But you see humidity is very less. So here you will feel the heat, but this will be a dry heat. Whereas the heat what we feel in Mumbai is humid. You will start sweating, but you will not, even the temperature at Delhi is higher, you will not sweat. Okay, because humidity is less over here. Pressure is standard 1003 hectopascal, visibility is 4000 meters. Little bit hazy is there, not much cloud, so it is a very clear, I would say clear weather is there in Delhi location. Okay, and if you see the METEOR over here, you can see the METEOR over here. If the forecast, okay, so the wind is little bit going to fly higher speed, so that is 12 knots. Visibility here it's 4500 meters, he is talking about 5000, so hardly 500-meter difference is going to change. Not much change in the weather, even though apart from the wind, rest is everything normal. Okay, but you see that maximum difference during the monsoon time, or probably especially during the monsoon, the weather would be differing it. Or if you would have seen the METEOR last week, it was very much differing because the weather over the country was differing from location to location. Right now, if you see the weather on India with respect to the satellite data, normally we see the IMD website. Okay, if you open the IMD website, you can see the satellite image over here, current satellite. If you see, not much of the worry part, little bit cloudy on the eastern coast. Okay, it is there, you can see here, but whereas the western coast is very normal, simple. Little bit cloud is there. If you see Delhi region, this part is not much worry part, it's more clear. Rajasthan or even your Gujarat, Punjab, these are more clearer locations. Only cloud is in the southern peninsula, like Maharashtra, Andhra Pradesh, Telangana, those location, and west Bay of Bengal, I would say. Okay, these locations you can see a cloud, maybe some kind of a cyclonic activity probably could come up in next couple of days. Okay, so we may see weather changing drastically on the eastern coast, because earlier last 2 weeks it was more on this side of the part because there was a lot of activity happening in the Arabian Sea. But right now it may be happening in the West Bengal or the Bay of Bengal location. So you will see maybe next 1 or 2 weeks you will see a change of weather over here. Not much worry part at our location. So if you see, we'll see cloudy, little bit hazy next couple of days. It may rain. It may rain, or very partial or drizzle kind of rain we would encounter at Igatpuri location. Okay, but not much to worry about it. So any questions on the METEOR or the weather report what we'll see? Or we are good to come back to our slides. Okay, so METEOR stands for Meteorological Aerodrome Report. METEOR gives us the required data such as wind direction, wind speed, etc. needed for safe flying. The drone operation, we need to cross check the METEOR for safe operation, safe and secure operation, where we don't risk the drone. Okay, so from a METEOR perspective, there are only two aspects what we need to see from a drone operations. One is the wind speed and second is the visibility, because we are currently flying under VLOS conditions. When we are flying for VLOS condition, we may have to consider location to location the wind, the weather. Okay, because that where the area of your operation will increase depending upon what you are performing. Whether it's a it may be a 5 kilometer flight, or it can be a 10 kilometer flight, or it can be 20 kilometer flight also, or it may be 50 kilometer flight also, depending upon what type of drone you are flying in VLOS conditions. Under VLOS conditions, you are flying a drone only within a range of, like say, 1 kilometer, 2 kilometer, max to max 3 kilometers, not beyond that, because beyond 2 kilometers your visibility will be zero for the drone. Okay, you cannot see the drone beyond 2 kilometers. That we'll see in the subsequent slide on how the visibility differs as drone goes away from your locations. Okay, so METEOR, there are several mobile apps also that provides real time. So normally since I do not have any current reference point for me to refer any METEOR for my drone flying location, because nearest airport, which is Nasik, which is almost 50, 60, 70 kilometers away from my location, so I cannot really rely on the METEOR report of Nasik airport. So I have to use some mobile app, which is technology advancement for currently, or maybe I have to deploy some mechanism to know what is the condition at my location. So we'll see that in subsequent slides. How do I interpret the weather at my location? Okay, but currently, because of the technology advancement, I have some apps available on mobile. So iPhone has its own weather app, which gives you the data point and all the things. But for Android phones, you can have a UA forecast, good to fly, drone cast, drone buddy, air data, UV, even Windy. So I have used Windy. I've been using Windy earlier on my Android phone, but now since I've moved from Android to iPhone, I have stopped subscription to Windy. Okay, so I'm using whatever the app is available in the iPhone. I used sometimes other apps, but then again it's not so reliable. Windy was much reliable and giving me more accurate on the Android. Similarly, on the iPhone also, the weather app what is available inbuilt, that also gives me a fair amount of forecast what is required for me. So it is more than enough for me to use those apps. Okay, so when you are talking about a pressure, okay, so international standard atmosphere, okay, that is ISA, what we call, is a static atmospheric model of how pressure, temperature, density and viscosity of Earth's atmosphere change over a wide range of altitude and elevations. So maybe at Mumbai there will be a different pressure, temperature, density and viscosity. For Igatpuri that could be a different, Lonavala it could be different, Mahabaleshwar it could be different, for a Kolhapur region it could be different, Goa it could be different, Bangalore it could be different, Hyderabad it could be different. So with respect to these locations, they have provided some kind of a table format data. Okay, it has been established to provide a common reference for temperature and pressure and consist of tables of values at various altitudes plus some formulas by which those values were derived. So when you study in detail about meteorology, you will see about more information about how these tables was created. Okay, these are reference tables which normally a pilot uses. There is a document which was published by ICAO, which has this kind of data. Okay, so ICAO published their standard atmosphere settings for different altitudes and different locations or elevations. So, however, at mean sea level, temperature would be standard, it will be considered as 15 degrees Celsius. So mean sea level as per the ICAO standards, the international standard atmosphere setting, the temperature would be 15 degrees Celsius. The pressure at the mean sea level will be considered as 1013.25 hectopascal. At mean sea level, the density would be 1225 grams per cubic meter. And the lapse rate, the last is the most important, the lapse rate is 1.98 degrees Celsius per 1000 feet up to 11 kilometers in height. So for example, at Mumbai airport, right now the temperature it is showing 31 degrees. I go to Lonavala, which is higher by 1000 feet. So what would be the temperature over there? Any idea? Any guess? Darsh, Arkodip, any idea? Any guess you can
No,
take?
sir. It will decrease by 1 degree, 2 degrees.
It will decrease by 2 degrees. That is what is the lapse rate what we do. So from a practical standpoint, we use the lapse rate as 2 degree difference every 1000 feet. So if I go to Lonavala, which is at the, it is not 1000 feet. Let's say if assume we are just assuming 1000 feet, it will be less than 2 degrees. So 31 it will less by 2 degree. It will be 29. Let's say Mahabaleshwar is 2000 feet. Okay. So again 2 degree less. So it will be 27. Like let's say Kodai Canal, which is 8000 feet. 8000 feet or 8000 meters. Okay. Just for understanding purpose. 8000 feet height. So 8000 means 8 into 2. So that will be 16. So 31 minus 16 will be how much? It will be roughly around 15 degree. So the temperature at Kodai Canal will be around 15-16 degrees. So it will be cold, right? Similarly, if you go to Everest or those locations, as you climb higher, the temperature reduces. Okay, that is what. So every 1000 feet, your temperature is reducing by 2 degrees. So it is 1.98. You are rounding it off to 2 degree. Okay, so it is 2 degree difference every 1000 feet. That is what the standard says. Okay. So there is a table which is being published by ICAO. So these standards have been published by ICAO, okay, in their weather and meteorology document. Okay, so type of pressure, yesterday we saw QFE, QNE. So QFE is what important from the drone flying perspective, what we said. It is a field elevation. So QFE is altimeter pressure setting at the takeoff location, which indicates the height. Okay, QNH is not nautical height. It is with respect to the mean sea level. Okay, so QNH is the altimeter pressure setting at the takeoff location reduced to MSL under the ISI condition, which indicates the altitude. So yesterday we saw, right, altitude means what? The elevation of the airport plus the height of the flight with respect to the airport. So that plus QFE plus the elevation is the QNH. Whereas QNE is nothing but the flight level, is altimeter pressure setting at the standard atmospheric pressure, that is 1013.25 hectopascal, which indicates the flight level. This is especially measured on your flight levels at the ocean, okay, because you do not have a reference. So that you take a standard atmospheric pressure at the mean sea level, and with that respect to the pressure, the barometric pressure will tell you what is the pressure. With respect to that pressure, you will calculate your altitude or the height, or what we normally called it as a flight level. So you will talk, when you're talking about QNE, you are talking about the flight level. When you're talking about QNH, you're talking about the altitude with respect to the elevation of the airport or the location. Okay. Whereas when you're talking about QFE, which is the height or field elevation, we are talking with respect to the ground of the airport. Okay, so normally QFE you will talk when you are approaching for landing, okay, or when you are probably trying to take off, or you have taken a takeoff, you climbing, you will say, okay, right now at 1000 feet, and now I'm going to climb about 2000 feet or 10,000 feet and all the things. Okay, just give me 2 minutes. Let me check who is calling me. Okay, so that's all about the types of pressure. Yesterday I have shared you a separate diagram also with respect to this, which will be more helpful you to understand it. Okay, again you can see here the altitude what we are talking about is QNH with respect to the mean sea level. So altitude is nothing but elevation plus height, whereas flight level is in the middle of the ocean, that is QNE with respect to the standard atmospheric pressure, that is 1013.25 hectopascal, whereas the height or the field elevation we call with respect to the airport or aerodrome, that is QFE. Even this diagram is very simpler and easier to understand the different pressure setting with respect to altitudes also. Okay, and vice versa. So pressure will vary with respect to the weight. So when you measure the pressure, will also help you to understand what height you are at. Okay, so pressure will vary with respect to height also. So as you climb up, your pressure will decrease. As you come down, your pressure will be standard. So at sea level, it is 1013.25 hectopascal. But as you go under the sea, the pressure will increase. Okay, that's why you see submarines. When they go deep inside the water, there is a huge pressure. The water pressure is also very huge. It is applying the pressure on all the sides. Okay, so possibly आपका submarine blast होने का chance. So your submarine wall has to be that thick to counteract the pressure of the as it goes down deep down in the sea. Clear? So as you go above, the pressure will decrease. The temperature also decreases. Your air becomes thinner as you go up in this. Your oxygen level drops. Okay, because of all these parameters. Okay, now that's about the pressure. Okay, and temperature we see. Now let's see the wind. So to measurement of wind is done by using a device called anemometer. Okay, it is a device that is used to find the wind speed as well as the direction. It can be in form of analog. Earlier in olden days, we have lot of time the analog anemometer. So those were basically nothing but 4 cups put on a ball bearing, and it used to move, and there is a gear mechanism which measures the rotation and gives you the speed of the wind. Okay, whereas now because of the technology advancement, we have converts this mechanical into a digital signal. So this is a digital anemometer which are pocket sized and compatible. You can carry anywhere. Okay, this is hardly like 300 or 500 rupees cost. It is available on Amazon, Flipkart platform also. So digital handheld anemometers are available in market, which drone pilot must always carry with them to cross check. Like right now, currently last 2 weeks, it was raining. Okay, so we have to rely on the digital anemometer. Sometimes we used to use windsock also. We'll see in the subsequent slide about the windsock also. So with the windsock also, like you would have seen it on the airport, aerodromes or weather station, windsocks are been put. Even some educational institutions also puts the windsock, because some educational institution also study or provide learning, or they are also doing research on weather and meteorology also. So they will deploy this kind of equipments in their premises also, or maybe some research facilities also would be having this kind of instruments over there. So analog anemometer, windsock and other devices, the measurement of temperature, humidity and all the things would be there. Like I had gone to one location in Kolhapur, okay, where they have the university has set up a one location where they were actually studying the atmosphere from one particular mountain. Okay, so they have set up the area with all these instruments over there. Okay, so it depends upon institution to institution, location to location. So wind speed should not be more than the permitted limit by the manufacturer at the time of drone operations. So whatever drones you are flying, you need to refer to your OEM document which specifies in what condition or what wind speed you can fly and what wind speed you should not fly the drone. So for example, our AgriBot drone, as per the OEM, we are not supposed to fly those drones above 15 knot of winds. Okay, if the wind is flowing maximum more than 15 knots, you should not be flying those drones. So if it is 15 knots, you should immediately land your drone. That is what they are saying. Okay, so apart from anemometer, there is a very traditional way which measures the wind speed and the direction is windsock. So windsock is nothing but a light flexible cylinder or a cone uh, mounted on a mast to show the direction as well as the strength of the wind, especially at the airfield. So I told you that at airport or even the aerodromes or even at the weather station, you will normally see this windsock. So it's a red and white small cloth. Okay, so this cloth is not actually a cloth, normal cloth. This is basically a waterproof cloth is being used so that it doesn't affect even in the rainy season. So this white, orange or red strips on wind 6 are basically they are indicating for relative wind speeds. So there are 5 sections in that. So if the first section is horizontal and remaining 4 are at bending, okay, or they are vertical, then you know that the wind speed is approximately 3 knots. If 2 sections are horizontal and 3 are in bend position, then it is 6 knots. If 3 are horizontal, then it is 9 knots. If 4 are, then it's 12. If all the 5 sections are horizontal, then it is 15 knots of wind. So it depends, it gives you the direction as well as the wind speed when you see the windsock. So the current position, what you see here, the wind, it is a complete horizontal over here, right? So this is the showing that it is flowing at 15 knots. The wind is flowing at 15 knots, and the direction. So at what the pointer is there, you can see the windsock direction. It will change the direction based on it. So it is basically showing you the direction as well as the amount of the wind speed what it is showing. So if it is completely all 5 sections are horizontal, your wind would be flowing minimum 15 knots or higher. Okay, so it is normal that below 15 knots it's a good normal operating wind. It is a pleasant atmosphere or pleasant wind, I would say. More than 15, you can feel the pressure. Even you cannot stand if the wind is more, right? It will be like create lot of dust and all that things also will come along with the high wind conditions. Okay, so let's see different types of wind. So gust is a sudden increase in wind speed, often change in direction lasting less than 1 minute, and it is a local effect. So understand when we say gust, so it is a local effect. It may be applicable in that only area where you are standing. If the person is standing 1 kilometer away from you or even 500 meters away from you, he may not feel the gust. Okay, so gust is a local effect. It is lasting less than 1 minute. Okay, so these are important. So wind speed often with a change in direction lasting less than 1 minute, and it is a local effect. It is called a gust of wind. Okay, after the gust, you will normally see a silence. There is no activity. So lull is a period without waves or wind. So that silence period normally we call it as lull. Okay, if the same sudden increase in wind but including change in direction lasting maybe for a minute. Okay, so squall is a sudden increase in a wind speed often with the change in direction. So both conditions are same, but here it is saying lasting for 1 minute or more. Gust was less than 1 minute. Here squall is maybe 1 minute or more, can cover a wider area. Okay, so gust was local, limited to area. Squall is more area, wider area. So that is called as squall. Okay, squall is really important to be predicted because you can see skull from very far location because it is covering a wide area. Okay, you can see that change in the behavior, change in the dust particles, change in the motions of the trees, and so you can predict the squall from a far location, maybe 1 kilometer, 2 kilometers, 5 kilometers. You can see the squall approaching you. Okay, you can see the change in the location, atmosphere, dusty, and all that thing. So squall can be predicted. Okay, you can see it at least sometime. You can anticipate and you can take care of your drone. So carelessness on the part of the squall can result in the crash of the drone, hence loss. So whenever you see the squall, you should immediately land your drone. Okay, you should stop your operations immediately because it can further lead to destruction. It can crash your drone because it is lasting more than a minute. Your drone can become unstable. Okay, it can be, the squall can be there for 5-10 minutes also. So in that scenario, your operation of your drone will be hazardous. So you need to take care of your drone immediately. Initiate RTL, RTH, or maybe immediately land the drone wherever it is. Okay. So that is how you can safely take care of your drone in case of squall. Okay. Next is gale and hurricane. So gale exists when the wind speed exceeds 33 knots. So normal wind speed is 15 knots. Double the 15 knots is more than 30 knots. So you will have a gale. 4 times the normal wind speed, that is 15 4s are 60. So 63 knots is where you get a hurricane. Okay. So in this both condition, whether it is a gale or in a hurricane condition of wind, normally you will not fly your drones because your drones will not be certified to fly in these conditions. We do not have a drone which can sustain because drones are not designed aerodynamically. There are fixed wing aeroplanes which are being sent into hurricane or flown during gale situation to study atmospheric conditions also, but they are aerodynamically designed so they can withstand this kind of wind also. Okay, so that's why fixed wing can be used but not a rotor craft. Okay, rotor craft are completely no because no OEM will certify to fly their drone in these conditions. It is very difficult unless you have a very powerful drone which can withstand or can be managed in such kind of wind. Okay, but it is currently we do not have any drone which can be flown in gale and hurricane conditions. Okay, so that's about the wind. Now let's see the cloud. Cloud is nothing but it's a mass of minute water droplets or a tiny crystals of ice formed by the condensation of water vapors in free air at a considerable elevation. So normally cloud is always up in the air above the ground. Okay, so as clouds are formed at some height over the surface of the earth, they take various shapes. Like when we saw on METEOR, it was talking about 2,500 feet or sometimes 4,000 feet, 7,000 feet. So there is a difference of height is specified. So right now, whatever the cloud we are seeing in Mumbai, they are hardly at 2,000 feet or 2,500 feet. Okay, so they are above the ground, but around 2,000 feet max. According to their height, expanse, density, and the transparency, cloud are categorized in 4 types. Okay, there are 4 types, but a lot of time you will read, people mix with these 4 types: cirrus cumulus, cirrus nimbus, cirrus stratus. They will mix these 2 types, but actually the proper definition is of only 4 types: cirrus, cumulus, stratus, and nimbus. Now we'll see in the subsequent how you can identify these type of clouds. Okay, so cirrus are formed at height of altitude of 8,000 to 12,000. They have a feathery appearance and they are always white in color. So recent times, if you see in the evening, you will see this type of clouds formation. Okay, whereas cumulus formed at 4,000 to 7,000. So they are little bit lower than the cirrus. Cirrus being very thin and feathery appearance, they are at very height, whereas cumulus are like scattered here and they are like a cotton wool. They are little bit bigger in size. The clouder, they are little bit heavier also. Okay, so those clouds will be little bit lower compared to the cirrus. So they are formed at 4,000 to 7,000 feet. So they are scattered here and there, and cumulus looks like a cotton wool. So you can see the pictures, 2 different pictures over here. Okay, sometimes you will see clouds feathery also, and you will see some clouds like a cotton wool also. But they are two different types of clouds. So don't try to mix. Some people will say, "Oh, I'm seeing cirrus cumulus." Which is a wrong definition. The type of cirrus clouds are cirrus clouds. Cumulus type clouds are cumulus only. So the cotton wool type shaped clouds are they are cumulus. Feathery appearance clouds are they are cirrus. Okay, so that you need to understand. You never should call mix. Cirrus, cumulus. People have habit or people have mixing this terminology over there. Okay. Next is stratus. These are layered clouds covering large portion of skies. These clouds are generally formed either due to loss of heat or mixing of air with the different temperature. So this type of clouds normally you see either in the morning or in the evening sky. Okay. So normally when the sun is setting or sun is rising or sunrise is happening, that point in time, because that time the temperature of the location with respect to it was a cold in the evening or sorry cold in the night, and all of a sudden sun rises, it starts hitting the air. So that time it's a mixing of air is happening. So you will see stratus cloud forming at this point in time or in the evening also. All of a sudden temperature was there, heat was there, sun is setting now, so temperature is getting lower. Okay, so as you see the sun is setting, you will see even the stratus clouds at that point in time. Whereas the nimbus cloud, there by the look itself you can make out this is normally during the monsoon. So black and grey are called nimbus cloud. They form at the middle level or at very near to the surface of the earth. They are extremely dense and thick. They don't have any shape. So they will cover the entire area or entire. Like if you see in monsoon, nimbus cloud will cover the entire Mumbai city or even complete even Indian peninsula also. So everywhere you will see these dark clouds. Everywhere it will be raining and all the things. So whenever it is raining, dark clouds, you see, you should understand that it is going to rain. Okay. So that point in time, you should make sure that you are not doing any drone operations. So any questions on the cloud, rain, cloud, or we can move forward. Right. So how does the weather impacts your operations, UAS operations? So cloud base at 9,000 feet, distance to the cloud edge is 2,000 feet. So normally you will have a less visibility in these conditions. Visibility is normally for a normal VLOS condition, that is visual line of sight, is less than 3 miles. Okay, so a lot of time because of the cloud and all the thing, your visibility will get reduced. Fog, cloud, precipitations, lot of time because of the fog or precipitation, icing, lightning, all this will impact your operations. Okay, even wind shear, all of a sudden wind will flow horizontally, also all of a sudden the wind will flow vertically also. That will also make your drone unstable. When you are flying the drone, like when you are doing practicals on 12th and 13th, you will see that sometimes even smallest wind shears will happen. All of a sudden your drone will shake. Okay, it will just move up and down. Either if it is a vertical रहेगा तो थोड़ा बहुत drone ऊपर नीचे हो सकता है, और horizontal रहेगा तो your drone will may drift. Okay, but because of GPS it will correct itself and it will try to become stable at that particular location. If GPS would not be there, okay, so what will happen? Your drone will change its position. It will go up and down, left, right, and all the things. So in that scenario, you may have to manually correct, bring back to your original position. Okay, but since GPS is there, the GPS coordinates will lock. It will provide the instruction to the flight controller. The flight controller will accordingly try to counteract that force which is getting applied, either vertical motion or horizontal motion. Okay, even in turbulent area also. Okay, so a lot of time because of turbulent area, if you're doing any fixed wing operations, okay, so normally the turbulence will affect when you are doing fixed wing operations. So during that time you may have to call out your mission, or you may have to reduce your mission, or maybe you have to divert your mission from the current path to some other path. Okay, that is how the weather impacts your US operations. So couple of more slides left and then we can go for a break. So cloud distance and visibility, as I told you, the visibility for a normal condition is around 2.5 miles or 2 kilometers, I would say. So now if you are standing over here, if you see here, you are standing over here, with respect to you 0.5 miles or 500 meters, you can see your drone very clearly. But as the drone moves away from you, it becomes less and less visible. Less visible to you. Okay, so you can't see it, or you can't make out the orientation of your drone, or you can't make out your heading of the drone also. So roughly around 1 kilometer or 1 mile, I can say, or 1.5 mile, you can see your drone very clearly. But as you move away, so standard is around 2.5 to 2.5 miles, or maybe 2 kilometers or 2.5 kilometers, I can say roughly, depending upon area to location, depending upon what visibility conditions would be there. Not necessary it is a very hard and fast that 2.5 mile तक मुझे drone दिखेगा ही दिखेगा. It depends upon type of drone. Like if you are flying our drone, it's little bit bigger compared to DJI drone. But again, 2.5 mile is very far for a normal small DJI drones. It's very difficult. Okay, our drone is quite big. It's 4 meter in size, so you can easily see that drone even at 2.5 miles. But I doubt at 2.5 miles you can see the DJI drone. Okay, you will hardly, if you are following it and tracking it, you can make out. But if you try to ask somebody to find out that drone at 2.5 mile, it would be very difficult for a person to find it. Okay, but if it is at 500 meters or maybe 1000 meters, I can see the drone little bit comfortably. Okay, again it depends upon size. Like aeroplane may be flying at, let's say, 10 miles away also, but I can still see it because the size of the aeroplane is quite big. That's why the size also comes into the picture. It's not only about the distance and visibility, but again the size of the, like I can see the mountains very far because the size of the mountain is very big, or the big buildings I can see from the far because the size is also plays an important role for the visibility also of that particular object. But वही अगर छोटा building है या small ship in the ocean is there, I cannot see. If it is a big ship, I can see it, like when it is very far. So that's how it matters. So size also matters for your visibility with respect to the distance also, as well as your visibility conditions. अगर visibility condition zero है, even the far off mountain will, even it's such a big mountain, will not be visible to you. Okay, so again, what parameter is affecting, that will give you the visibility of the particular object. Okay, so cloud and fog, how do the cloud and fog differs? Both are same. They are both formed from the water vapors, but cloud is always above the ground, whereas fog forms at the ground area. Okay, so cloud can form at many different altitudes, while fog only forms near the ground. Okay, that's why so in the winter season, lot of time you see the fog forming near the ground or near the watery bodies or in the valley. If you have gone to your native place or a remote areas, you will see, the ground is covered with the fog, so your visibility is very less. So you can see something like this. Okay, so this normally if you go to Lonavala, Igatpuri, you will see this kind of conditions. Especially if you go to Igatpuri even now, early morning you will see it foggy. Okay, but over the period time, like in afternoon, the fog will get cleared. Again, maybe in the evening the fog will form, and night also it will fog. Again, early morning you will see fog. Only in the afternoon you will not see fog. It will be clear out. Okay, so it will get reduced. So this is again depending upon location to location, area to area, and depending upon what weather conditions you have for that particular area. Like now, normally if you go to Lonavala at Tiger Point, you will see the fog forming at that location early morning or in the evening. Okay, whereas in daytime, if you go in winter, every time there is a fog. Okay, over there, so visibility is very low at that point in time at that location. Similarly, in Igatpuri also, when you go in the rainy season, every time there is a fog. Okay, so that's why it is called fog city also. Okay, so icing is also very important. Normally this is very much concerned in the civil aviation. That's why you see the bigger aeroplanes like your Boeing or Airbus, they have a de-icing functionality fitted. It's nothing but there are heat coils. Okay, so whenever the pilot sees that icing has happened on the wings or the body structure, they will activate the de-icing functionality. Okay, which will heat up the body of the aeroplane, the wings of the aeroplane, and automatically that icing or the ice what is formed on the wings or on the body, it will melt. But smaller aircraft like Cessna, older Cessnas may not have the de-icing functionality and all that. So in that scenario, it's very difficult to remove the icing. But then if you fly with the icing condition, it will impact the performance of your aircraft. So in that scenario, you will ask the local airport or the aerodrome to provide a hot water. So normally they will spray the hot water on the body or the wings of the aeroplane, so which will actually melt the ice, and then you are good to fly your aeroplane. Okay, in drone you don't have to worry much because you will not affect much about the icing. But in case you are flying the drones in those conditions like European conditions, Kashmir, Ladakh, those colder locations or high altitude locations where you have this icing issues, you may have to take care. Right now we do not have a drone which has a de-icing functionality, I think, but then you have to clean it up. Okay, maybe you have to manually remove the ice formed on the drones because it will affect the performance or make your drone little bit heavier also. Okay, so it will may have to generate more thrust with respect to the icing conditions. Okay, so lightning also forms. So lightning cause thunders or sound of shockwaves. This basically impacts your communications, your communication from RC to the drone or from drone to your ground control stations or your monitoring stations also. That time sometimes you may have momentary loss of signals also. Okay, so you normally avoid flying your fixed wing operations or maybe your drone operations in lightning conditions. Like people sometimes fly drone near the volcanic eruptions to monitor or see the volcanic activities and get the footage of it. So in that scenario also, when the lightning is happening, you normally will see the disrupt in your communication signals or loss of signals at that point. Okay, we talked about the wind shear. That's the horizontal movement of the wind or the vertical movement of the weir. In this scenario also, normally you see if it is a longer time of wind shear, this can also affect your drone operations also. So accordingly, type of wind shear and all the things and how it is affecting your mission, you have to take a call whether you have to divert or whether you have to abort your mission. Accordingly, you have to take a call. Okay. Last is the turbulence. Turbulence is nothing but a sudden violent shift in airflow caused wind, storm or jet stream object near particular the plains, particularly in the mountain ranges. Okay, so normally fast wind, slow wind, and this will cause the turbulence around your aircraft. So normally when you are flying a normal civilian airlines or commercial airlines, you will feel this turbulence. Okay, so normal light turbulence is okay because that will give you hardly manageable shift in your altitude. It may be 1 or 2 meters up and down. Your aircraft will go up and down. So you will see that you will feel, but it will not be much worry part. Moderate is little bit worry because there is a major change like 3 to 6 meters. Okay, so at that point in time, possibility if you have been served with liquid drinks like water or tea, coffee, and all that things, that time people will say that maybe you have to hold a cup or something, or maybe you have to stop serving those kind of activity and all this. Okay, whereas severe where it is up to 30 meters, so which is very dangerous. So that point in time you may communicate with ATC and ask for change of altitude or maybe change in flight path also. So based on the observation, ATC will guide you, either you may climb or may descend or may change or you may alter your course of flight plan also for certain amount of time, and then you can come back again once you are away from the turbulent location. You may come back to your original flight path. Okay, so that's how the weather and meteorology is important with respect to the civil aviation. From a drone perspective, you have to understand the height at what the operations you are going to conduct, the location of what operations where you are going to conduct, what is the wind speed, temperature, and the visibility. These three parameters you need to observe before your flight. If everything is suitable and feasible condition, then only you should carry out your drone operations. Okay, clear? Any questions so far, or we are good to go?
No, sir.
With that, we have completed the topic of weather and meteorology. We'll take a 10 minutes break. So it is now 12:24. That means 12:25. We'll come back at 12:35. Okay.